Okay, returns to scale. Now what happens if all inputs, they're increased proportionately? Okay, that is, you have labor, you have capital. You double the amount of labor you use and you double the amount of capital you use. Then what will happen to output? Will output double? Will it less than double? Or will it greater than double? So for example, you have the production function. You increase the amount of capital and labor. You double the amount of capital and labor. Now, this is the original production function which you have. Now, in case if the output exactly doubles, that is, you double the amount of inputs and it doubled the output. So, doubling inputs leads to doubling of outputs. Okay, that is, your FKL was just say 2Q. Now, in this case, this is the case of CRS. That is constant returns to scale. You increase your capital and labor to 3 times, your output would increase to 3 times. So that is constant returns to scale. IRS is basically you double the amount of inputs which you have, but the output would more than double. Okay, output would more than double. So doubling the amount of inputs, output more than double. See, this side is not doing anything. This side is just doubling your output. Your initial output was FKL. You double your output is 2 FKL. Now this side is actually telling you something. Your left hand side. It is telling you whether the actual output would double, it would more than double, it would exactly double. Okay. So I'll give you an example also. FK, in case if it is 2K2L, it would less than double the output. It would less than double the output. Okay. Well, this is the case of IRS. This is the case of DRS. Okay. Let's say you have the case of your Q is equal to K square L square. This is Q is equal to root of KL. And this is, say, Q is equal to min KL. So initially all of them say they used 1 unit of capital and 1 unit of labor. Okay, so according to this it would be min of 1 1. It will fetch you output of 1. This Q would be 1 square into 1 square. This would also be 1. Here, this will also be 1 because this is root of 1 into 1, which is just 1. Okay. Now you double the output. Double the output would mean what? In CRS, it would be 2. This would be 2. This would also be 2. Okay. You double the output. Sorry, double the input. It will be min of 2 2, which is giving you 2. Here, min of 2 square 2 square. It will give you 16. 4 into 4. And here, this is also giving you just 2. Okay. Oh, this is the wrong production function which I have taken as an example. Let me just change it to k to the power 1 by 3 into L to the power 1 by 3. Okay, let me just write it here. Your Q is basically equal to k to the power 1 by 3 L to the power 1 by 3. Okay, so in this case, what will happen? Okay, what should I do? So, for example, if I have the initial inputs as your k is equal to 1, L is equal to 1, okay, it would have fetched me Q equals to 1. So supposedly if I if I change the inputs to say 8 to the power 1 by 3 into 8 to the power 1 by 3, it'll give me 2 into 2, which is just 4. So you increase your inputs to 8 times, but your output increased only by 4 times. Similarly, supposedly if you increase your inputs to 27 times, and but still your output would increase just by 9 times. So this is the case of DRS. I'm sorry, I've given you a wrong example here. This was the case of the CRS. Q is equal to root of KL and Q is equal to KL or min of KL. These are all CRS functions. So now graphically, let us try to understand what does it mean. It means in case of CRS, what is happening? Your K1 and L1 is say this point, okay, and it is on this Q isoquant, let's say Q1. Now you double the amount of the inputs, you double the output, which is say Q2, but this Q2 is nothing but just 2Q1. So this is your isoquant. In case of DRS, what is happening? This is your L1 K1, and you double the amount of inputs, you move to another isoquant Q2, which is less than 2Q1. Okay, say for example, in case if your doubling of your doubled isoquant is maybe this. So it is less than double the output. In case of IRS, what is happening? Say you double the amount of input, you are on a different isoquant, which is say Q2, which is more than double the amount of an isoquant here. Say for example, your doubled isoquant was this. So this is an example of returns to scale.